Good morning. Good morning to all.
Good morning, sir.
Only two people have joined. Can you wait for another 2 3 minutes? Okay, let other people also to join. Okay, let us start. Is my screen visible to your end? Can you look at the screen?
Visible.
Is it coming right?
Yes, sir.
Okay. So yesterday we were doing the analogous between rotational and translational motions. Okay. So moment of inertia in translational part it is called mass. Fine. Angular momentum, angular the rotational, angular momentum, linear momentum, angular acceleration, translational acceleration. So those things we have made a table and we have discussed about that. So now are you clear about that? Are you all clear about that? I'm asking. Is there any doubt regarding the last class?
No, sir.
So let us move to new topic that already you have gone through it. Still, it's necessary from solid mechanics point of view. One is your perpendicular axis theorem, another one is parallel axis theorems. So this is not new to you. Still, I just want to give a remind, just brush up your ideas. Okay. So let us start. So this is perpendicular axis theorem. Okay. Let us write the statement first. Suppose you have a lamina like this. Okay. This is x-axis. This is suppose y-axis, and you are asked to find the moment of inertia about a axis passing through the point where the other two axes meet and perpendicular to the plane. So this is a perpendicular line. Suppose z-axis. This is perpendicular. Okay. So statement is it states that the moment of inertia of a plane to plane lamina about an axis perpendicular to the perpendicular to the Lamina about axis perpendicular to the plane of the lamina. Plane of the lamina is equal to the sum of the moments of inertia the moments of inertia of the lamina about two axes about two axes perpendicular perpendicular each other in its own plane and intersecting each other intersecting intersecting each other intersecting each other intersecting each other at that point at that point where the perpendicular axis passes through perpendicular axis passes through it. Okay. So if Ix and Iy be the moments of inertia of a plane lamina, you first write down. I will come back to it. Lamina about the perpendicular axis about the perpendicular axis x and y respectively which lie in the plane of the which lie in the plane of the lamina plane of the lamina and intersects each other intersects each other at O, its moment of inertia I. Moment of inertia I about an axis passing through axis passing through O. Passing through O and perpendicular to it to its plan is given by I equal to Ix plus Iy. So what is this statement actually? Let me make it more clear. So suppose there is a lamina like this. Okay, lamina is a part of something, flat plate, flat, or you can say flat plate. Okay, suppose you have to find the moment of inertia about an axis passing through its center or maybe some other point and perpendicular to its plane. Then if you have to find suppose I about CD, you have to find I about CD. Then what is the procedure? You draw two perpendicular axis, okay, perpendicular axis, suppose x and y, at the same point through where to which the axis CD passes. So important point is that CD is the perpendicular axis and x and y are mutually perpendicular, but both of them lie on the plane of the lamina. Okay, so is it clear? Am I clear to all? CD is a perpendicular axis and XY are also mutually perpendicular, so they are orthogonal actually. They are orthogonal, and this is also orthogonal to it. Okay, so in that case, you find first your Ix and Iy, then add them up. Add them, you will get this equation. Is it clear? Is it clear to you? Hello? Is it clear to you?
Yes, sir.
Okay. So let us move to the next theorem. So in this, we are not going depth into it. We are not going to the derivation of it, but from engineering point of view, we need the application. So its different applications may be like, suppose you have a flat bar of this kind, okay, and you have to find the moment of inertia about an axis passing through any point, suppose this point, and perpendicular to the plane. So you have to find the moment of inertia of this particular thing. Okay, suppose you have to find the moment of inertia of a dish, that you can find out. Suppose all these are perpendicular axis. Suppose you have a figure like this, geometrical figure, That means 1/4 has been cut out from a full circle. So there you have to find out, suppose, moment of inertia. This is the center, but you are not asking to find the moment of inertia about the center, but you are asking it at a different point. So this type of problems you can solve by this perpendicular axis theorem. Okay, but during competitive exam you will not get that much of time so that you can derive, you can get the answer. So there are some direct formula, or rather we can say shortcut. Some shortcuts are there. So if you look at some books or if you search, then you can see that some shortcuts are available for this type of geometry. Okay, there are many geometries are there like that. Fine. So in competitive exam, normally what they ask, they will give you one any kind of shape, and you will to find the moment of inertia. So then you have to apply, you have to go for either perpendicular axis theorem or maybe parallel axis theorem, depending upon the problem. Okay, so that from that point of view, it is important. Am I clear? Am I clear? What is the use of this perpendicular axis theorem? At least anyone can speak. No, nobody is having the same network issue at the same time. I can understand that.
Yes, sir.
So let us move. Parallel axis theorem. So again, I am telling you that this is not a new thing for you. You have already have studied all this stuff, but for your brushing up only thing, I am doing it again. So again, parallel axis theorem, it states that, write the statement first, states that the moment of inertia of a the inertia, it states that the moment of inertia of a body about an axis, about any axis, is equal to its moment of inertia is equal to its moment of inertia about a parallel axis about a parallel axis through its center of mass through its center of mass. So what is a center of mass? Center of mass plus the product of the mass product of the product of the of the body mass of the body and the square of the distance between the two axes. Two axes. So I is equal to I center of mass plus m r square. Okay. So now, so you know about center of mass. What is the center of mass? I'll come to that point later. Let me make you understand this equation first. How this equation we can derive it. We are not, again I'm telling, we are not going the complete derivation of this particular equation, but I'll just give you the hints. I will give just the application point of view. Okay. Suppose this is a lamina. It is having mass, suppose m. Okay. Now I'm asking you to find the moment of inertia about this axis. Suppose AB. About AB, I am asking you to find the moment of inertia. This axis is not lying on the plane. Okay, it may be perpendicular to the plane, it may be parallel to the plane, no problem. So in that case, what you have to do, you have to consider the center of mass. Suppose this is the center of mass. So see, let's remember, center of mass may not be the center for a irregular body. For a regular body, for regular disk, center will be the center of mass. But for a irregular body, you cannot say that center will be the center of mass. So this is some arbitrary point. Let us call this point O. And what is O? O is your center of mass. Fine. So O is the center of mass. Now from O, you take the normal distance. Suppose this is r, and also draw another parallel line parallel to AB. Okay, let us call this CD. Fine. So what is m? It is the mass. What is O? It is the center of mass. Okay, and this is the parallel axis. These two are parallel. AB and CD are parallel. So in that case, what we will get, the equation is, হ'ব দিয়ক নহ'লে আছে নেকি এক্সট্ৰা থেংক ইউ so fine, that is the moment of inertia moment of inertia of the lamina about the axis AB is equal to each mi means moment of inertia of the lamina about a parallel axis which we call CD through its CM or center of mass through its center of mass plus mass of the lamina, that is M, mass of the lamina into distance between the two axes raised to the power 2. So this is what parallel axis theorem. So what is the center of mass? Let us come to the center of mass. Center of mass. So have you remembered center of mass? What is it? Suppose I have a body like this. Okay. So total mass may be m. This is the m total. Am I clear? Till perpendicular axis theorem or parallel axis theorem. Am I clear to you? You need more explanation? Do you need more explanation? Deepak, Dushman, do you want me to repeat? Nizar
Yes,
Alfi,
sir. Repeat one more. Once more.
do you want me to repeat?
Yes, sir. Repeat once again.
Which one? Parallel or perpendicular?
Parallel.
Okay, parallel axis. So what is the parallel axis theorem? Okay, let us come to again. Okay, center of mass we will do it later. So parallel axis theorem is suppose you have a regular bar like this, and I am considering it to be isometric, uniform. That means its density is uniform throughout the material. In that case, you can safely say that L by if it is L, then center of mass, suppose O, will lie at L by 2. Since I am considering it as a uniform material, isometric. Okay, so you can say that center of mass will be the middle of the bar. Okay, now if somebody asks you to find a moment of inertia about an axis passing through its edge, let us call this PQ. If you have to find the moment of inertia of this particular bar about an axis passing through its edge PQ, so what you will do? So in that case, you draw one perpendicular axis, sorry, not perpendicular, parallel axis. Suppose P prime Q prime. So what is the condition? PQ is parallel to P prime Q prime. Okay. Now, if I have to find moment of inertia about PQ, what you have to do? Moment of inertia about the center of mass, that you have to find out. Center of mass means here it will be O, plus let the mass of the bar be M. Fine. So ultimately it will come M into, and let us consider this distance. How much it will be? How much is distance? Please tell me. How much is the distance? Tell me. What is the distance? Alright, that has been already shown. L by 2. So L by 2. In place of R, it will be now L by 2. So then you calculate this one. This you will get it because M will be given, L will be given. After that, you can find your PQ. Okay. So you can find your PQ. Now is it clear? Now you don't ask me how this equation we have arrived at. For that we have to go for the derivation. That I am not going into it. I am just showing the application. Am I clear? All of you please respond. Nizar Alfi, are you there? Nizar? Where is he? Nizar Alfi, yesterday also he was not there. Yudhishman, these things are not going well actually. If people just switch on your laptop, mobile, and then you roam around here in there. Bhagirath, are you there? Hello? At least you can unmute. Others is there, Alika is there, Bhagirath, Deepak, Nijar Alfi.
Yes, sir.
Who is that, Bhagirath?
Yes, sir.
Nijar Alfi is not there. Jyotisman is also not there. I have to talk to them personally. I don't know what is their problem.
Okay, sir.
These two persons, Jyotisman Bora, see, he is not unmuting his mic. Nijar Alfi is also doing the same thing that he has done yesterday. Deepak, are you there? Deepak, yes, he is there. Okay, now let us come to center of mass. So, what is the center of mass? Suppose this is your body, m is the total mass. So you can get some constituent mass forming your whole body, because you know na, the every cell construct our whole body. The basic unit of our body is a cell. After that tissue will come. After that what will come? After the tissue organ. So this type of things, no. So there are many small particles that constitute the total mass of the body. Let us call every particle, suppose m1, another one is m2, m3, m4, like that mn. So if you take the summation of mi, I varies from 1 to n, that will give you the m total. Okay, so now what is center of mass? You cannot directly say that the center will be the center of mass. It's not like that. Suppose every mass is acting on the downward direction, as we know, gravity pulls. Okay, so these are all factors, then combine them together, supercompose that, and you will find one resultant vector that will be on the downward direction, and that point, particular point, is called center of mass. Okay, that means, let me draw the free body diagram. Let me draw the free body diagram. Suppose you have a vector like this m1, another vector like this m2. This length will determine the amount of mass, suppose m3. Then take the vector sum, fine, and ultimately you will get one resultant vector, that will be your center of mass. The point through which the resultant vector will pass, that will be your center of mass. Okay, and what is center of gravity? What is center of gravity? You just find out. Fine.